Hello and welcome to my presentation about my paper on attention-based methods for multi-level facial action unit detection in the ABAW 2022 competition. My name is Guee and I come from Smart Computing Lab of the Chennai National University in South Korea. The ABAW competition contains three unit tasks and one multitask. We participate in the action unit detection task. The task is run on effect while two datasets. This is annotated by frame-by-frame method for multi-label classification, and the performance measure is the macro F1 score across all action units. Here are some video frames I picked from the book, the provided dataset. The facial action coding system refers to a set of 46 action units related to facial muscle movement corresponding to facial expression. The coding system was invented by Eunchae and Rosenberg in 1997. We observed that for action unit detection tasks, the model should selectively focus on specific muscle of human face to capture the meaningful visual information for predicting the action unit. From this observation, we design our method contains two main components as shown in the figure. First, our model receives a single image as the input. Then we feed the image into the feature extractor to get the visual features. Next, we apply an attention module to calculate the attention encoded vector from the feature map. And finally, since the task is multi-label classification, so we use the sigmoid function to produce the final output. For the feature extractor, we build a custom CNN extractor rather than using pre-trained state-of-the-art models such as ResNet 50, InsertionNet, or EfficientNet. The reason is when we compare the experiment results, we figure out that using custom CNN achieves the highest performance. We simply construct a set of six convolution blocks interleaved with McPolin layer. A convolution block is a sequence of 2D convolution layers followed by a path normalization layer and a ReLU function and an activation function. For the attention module, we leverage the same attention mechanism described in the global local attention for emotion recognition paper. First, the feature map with the shape of H, W, and C will be divided into a set of S times W of element-wise subvector. Notice that each subvector has C elements, and the figure illustrates this process. Next, a fully connected layer followed by a path normalization and ReLU layer is added. Then one unit fully connected layer is employed to compute the attention score of each subvector. Finally, the attention encoded vector is obtained by a weight sum of subvector and their attention score. Moreover, from the dataset statistics, we can see that the dataset is imbalanced. To solve the imbalanced dataset, we optimize the model by the class weight binary cross-entropy loss function. We calculate the weight of each class by the ratio of the number of total training samples over 2 over the number of positive samples of this class. Then we multiply the weight to the positive loss of the total loss. Here are the experiment results. We get the improvement result on pole validation and testing set compared to the baseline model. On the validation set, we achieved 48% of F1 score, 9% gap to the baseline. On the testing set, we get 42% compared to 36.5 of the baseline. The experiment results prove 3 points. First, using custom CNN network achieve better results than other pre-trained state-of-the-art model. Second, attention module have been shown the effectiveness for the action unit detection task. And third, Reweight binary cross-entropy loss can be used to tackle the imbalance dataset for the multi-label classification task. In summary, we saw that by using the attention mechanism and weight binary cross-entropy loss in the deep convolutional neural network, we can improve the model performance in the task of action unit detection. You can refer my code in the URL. Thank you for watching. I welcome on for any question.